Assalamu alaikum and a very wonderful welcome to everyone. Welcome back to the Integrated Design Project KIX 3001. Now we've looked into the first topic, which is on virtual project management. Really hope that it actually helps you in managing projects virtually among your friends, and you can actually see or distinguish the very best setting for this type of setting at the moment. And now we're going to move on to Foundation Structure Design Report before we move on to the last topic, which is on site preparation. Now here are the detailed table of content. So Foundation Structure Design Report. Firstly, you need to understand what's the difference between client, geotechnical engineer, and structural engineer. Let's read this. Now A, the required base area of a footing may be determined by dividing the column load. Oh, sorry, it's too big. Okay, and let's just change color to this one. Okay. Let's go for highlight. Okay. So you divide the column load by the allowable bearing capacity. So this was explained in foundation engineering, where allowable bearing capacity is always the main thing in your foundation design. Now, determining the thickness and shape of the footing and amount and location of reinforcing steel and performing other details of the actual structural design of footings are, however, ultimately the responsible of a structural engineer. So this is the role of a structural engineer. Now look at B. In general, a geotechnical engineer furnishes the contact pressure diagram and the shear and moment at a section in the footing at the face of the column, pedestal, or wall. From this information, the structural engineer can do the actual structural design of the footing. So it is mandatory for your group to have a geotechnical engineer and structural engineer to work alongside in order to come up with this result. And then C, the chief designer should report the result of the foundation to the client or the owner in a form of foundation structure design report. So the chief designer should be your group leader, and the owner or client should be us. And D, the foundation structure design report shall include assumptions made during the design, a summary of the geotechnical information, action, characteristic values, design calculation models, calculation procedures, and design verification methods for all limit states considered. So all of this is inside this foundation structure design report. It is recommended that the foundation structure design report include but not be limited to the following items. So a total of 11 important information you need to provide in the report. But if you don't have, then it's okay. Just fill in whatever information that you have on your part. Okay. Now the first one we'll look at description of the site and the surrounding condition. This is pretty important so that the client or the authority will know where is the exact location of your site. For example, in this picture here, the site is here and it's located at a bridge structure, there's a motorway and there's a school and so on. This gives you clear perspective or information on the site's location and surrounding. Second is the ground condition. You've been assigned with a simple ground condition before, so please insert that in the report and just briefly describe whatever you see in that report. So this is an example of a complete ground condition from the site investigation. You have a very detailed layers of soil over here, the depth, and the west and east direction. The third important thing inside the report, it should be from the structural performance criteria and design situation. Now what is it? So the client or the owner of the structure should determine the design working life of the structure. The design working life of a structure may be determined by considering various factors including life cycle cost, durability, and deterioration. If you are unable to provide all this, the main important thing you should know that the design working life of structure is generally 100 years for civil structures and 50 years for buildings. Now let's move on. Now these are the things that you've been briefed in your RC design, where in principle you have 3 types of limit state for your design of your structure. First is the serviceability limit state, repairability limit state, and lastly is your ultimate limit state. So you should be well versed about this during your design of your structure. Now let's look at the next item, which is still under item number 3, but the second one, which is on your loading. So you should know that when you design something, it must be based on a loading or design situation. And for this for this design situation, you have a total of 4 types of loading, which is permanent, variable, accidental, and temporal. Each one of these should correlate or should represent with all these types of loading. For example, permanent will only refer to the self-weight, fixed load, static earth pressure, and hydraulic pressure, and so on. And for variable, it should consist of live load, accidental, and so on. So you should know or take care into account of this respective loading very carefully. You can't have permanent load design in your variable load. Now let's look at number 4, description of site-specific action. For example, earthquake action. Now this one you should always report to the client and the authority whether that site is risk in any natural event. For example, earthquake event, you should always notify the client if it's in a high-risk earthquake location or a low-risk earthquake location. If you don't have, then you just forget about this. Number 5, characteristic values of the geotechnical parameters with a justification of the determination. You can all skip this because this is done by the geotechnical consultant, where they provide you with the SI report. But in the future, if you were to have this report being established, you should always contact your geotechnical consultant and provide all this information. Number 6, description of the design codes and supporting documentation. In any of your design, you should mention all the design codes that you use, from the structural design code to the foundation design code, what type of code you should mention. So here there are 3 types of code: comprehensive design code, basic specific design code, and the specific design codes. Item number 7, justification of the chosen foundation type. So the client or your boss should know why you should choose this type of foundation, and you know that foundation are classified only in just 2 groups, which is the shallow foundation and deep foundation. You should give a very good justification or reason of why you choose type of foundation for your structure. Number 8, more to CPM, is on structure risk and a justification of the safety margins against various limit states. So in the end, you come up with this risk table. Number 9, in CPM, assumption for the construction condition. These are the terms and conditions that you provide between you and your client so they understand more about the project. For example, for the first item, scope of work, the more detailed the scope, the more certainty they can be on the price, and so on. So if you're unable to provide this in your report, then it's okay because it's more towards CPM, but just like to acknowledge you that this exists in the report. And 10, calculation and drawing of foundation structure, which is important because this is the main core of your report. 11, description of the required monitoring during construction and a check of the item for the maintenance of the structure. This one, if you have, you can put. And lastly, the geotechnical investigation report and the foundation structure design report shall be achieved by the client or the owner for the entire service life of the structure. That's the end of the chapter number 2. But before we leave,